in Great Falls, Maryland, as you can probably tell by all the activity around here on a really nice spring day. But this was chosen as the headworks for the Washington Aqueduct because the river falls somewhere around 40 feet through Great Falls. So what the Montgomery Meigs recognized was that he could take advantage of that fall in the river and get water down into the city by gravity and thus saving money on pumping. So what we have here is the Great Falls Dam that was constructed to divert water from the river into the intake. And the original intake is behind me. That's what we call the Great Falls Gatehouse, and that's 1854 construction. It was constructed to control the flow out of the river into the conduit and heading down into the city. This is the Great Falls Dam we're looking at now. The dam was the first facility to be constructed and one of the key elements to the water supply. The purpose of the dam is to divert the river water into the conduit. As you can see by looking at it and the flow of the river at this point, and it's even a dry period now, so this isn't even a high flow. It must have been a huge effort to divert the river around so that the crews back in the 1850s could even get out there to construct this dam. The dam was constructed, like I said, one of the early facilities, and then the old conduit continued from about this point back to the gatehouse and then on down to the capital city. Now, what you're seeing here now is the new gatehouse. It was constructed in 1970 and it incorporated both the old and new conduits. So at that time, the head wall to the old conduit was modified. The new bar racks were put in. So what you're seeing now isn't exactly what the old conduit looked like when it was constructed. But the dam, with a few modifications, is the original dam. The water is diverted from the dam into the conduit, which is a 9-foot diameter pipe. The conduit from the river crosses under the canal and then into this gatehouse. This gatehouse is the 1854 construction. It was constructed for the purpose of controlling the flow out of the river and into the conduit. So the water comes in, makes a turn. There's a lineup of sluice gates here that were operated by hand. The operators would come and raise and lower sluice gates to control the amount of water that's flowing into the conduit. Right now we get a real good look at the conduit and the sluice gates in this building because the conduit's out of service downline for repairs. So this conduit is currently not in operation, although under normal circumstances, were it not for construction, there would be water flowing through here that would eventually become drinking water for the residents of DC and Northern Virginia. Well, these sluice gates here are original 1850s construction, and we actually use sluice gates today. They look very much the same. They operate in very much the same way, except by means other than manpower. This is the stem. You can see it's threaded. The sluice gate is down below. It's, if you will, a plate on a track, and by turning this mechanism inside, the screw is threaded up and down. You can see that these gates are in their open position because the screw is all the way up. If in 1850s they wanted to close this gate, they would use this device right here, which has a ratchet type device in here, and a man would push on this, which would in turn turn this sprocket here and screw the shaft down, and as the shaft goes down it lowers the gate, and that would be the closed position. So every time one of these were opened or closed, it would take a big guy pushing on this device to get the gate closed. Most of our sluice gates now look very much the same screw, the same gate, the same guide, but in a lot of cases, this device is replaced with either an electric operator where you'd push a button and a motor would turn it, or a mechanical operator that's driven by a fuel-powered machine where there would be a nut here and the machine would turn the nut and that would turn the screw. But the gate itself looks very much the same, just not quite as much manpower opening and closing it. Well, we're here in the middle of MacArthur Boulevard, and MacArthur Boulevard used to be known as Conduit Road. It was constructed for the purpose of accessing and maintaining the old conduit, which runs all the way from Great Falls down to the reservoir at Dalcarlia. The conduit actually picks up MacArthur Boulevard at Angler's Inn, and the center line of the conduit and the center line of the road are the same line, and that continues all the way down to about the Defense Mapping Agency. The old conduit, which was constructed in the 1860s time frame, runs down the center line of MacArthur Boulevard. The original conduit actually first went into service in 1864. The Cabin John Bridge was the last link between Great Falls and Dalcarlia. So from 1864 until 1923, the conduit was the sole source of raw water for the Washington Aqueduct system. In around 1920, the Corps of Engineers started studying for expansion. There were growing demands on the water supply. The capital city was growing. People were becoming accustomed to having public water supply available, and the demand was just growing leaps and bounds. At that time, in the early 1920s, a second conduit was constructed parallel to the original conduit. To give you a current landmark, there's a hiker-biker trail on the riverside of MacArthur Boulevard, and the new conduit runs down the center line of that trail. So the two run parallel down MacArthur Boulevard, and then with that construction, that 1923 construction, the Dalcarlia treatment plant was constructed at that time as well. Well, this is one of three interconnections. The 10-mile conduit from Great Falls down to the Dalcarlia plant is broken into 4 sections by way of these 3 interconnections. This one is at the intersection of MacArthur Boulevard and Goldsboro Road. There's one on MacArthur Boulevard up near David Taylor Model Basin, and then the third one is back down the path from Angler's Inn just a ways. This is one of the sluice gates, same equipment that we saw up at the Great Falls Gatehouse used to open and close to move the water around. So from down below, you can get a good idea of how the water moves through the interconnection. This is inside the interconnection. What's happening here is the old conduit is flowing through, and these sluice gates that are above me, there are 4 of them in this chamber. The sluice gates control the flow of the water flowing in the old conduit. Right over here is the sluice gate that interconnects with the new conduit. And what this does is, under normal operating conditions, both conduits, the old and the new, would be flowing full. That's how we get the most amount of water down to the plants. But if we needed to cross over or shut one conduit down for construction, or if we had a problem up at Great Falls at the intake where debris was clogging one of the intakes, we can use these interconnections, and by manipulating these sluice gates and that sluice gate, we can cross the water back and forth between the old and new conduit to get the most amount of water down to the plant and still be able to work around our hurdles, be it construction or a log jam up at Great Falls. So there are 3 of these interconnections along the way, and it allows us to have a lot of flexibility and water flowing down through the conduits. Now we're in the old conduit. This is about halfway down from Great Falls to to Georgetown, or to Dalcarlia. The old conduit throughout its whole section is a 9-foot diameter pipe. The section that we're in right now is a concrete section, but the material of construction changes as the conduit construction progressed. Up at Great Falls, the conduit was mostly cut in bedrock. There are brick sections, there are concrete sections, there are stone rubble sections. They used whatever material was available to them during the 11 years of construction. What you're looking at here is, like I said, the original old conduit, probably since we're about halfway down, I would say maybe 1858 time frame, somewhere between the start in 1854 and the completion in 1864. This conduit carries about 50 million gallons a day of raw water to the Dalcarlia Reservoir. The actual capacity depends on the level of the Potomac River and how much head pressure there is to push the water down, but about 50 million gallons a day. As the conduit construction progressed down from Great Falls, there were several small ravines and one large one that had to be crossed along the way. There were culverts constructed to carry the water course under the conduit and then the conduit over. Those culverts can be seen along the way. The one large ravine that had to be crossed was here in Cabin John, and Meig's solution to that was a bridge, the Cabin John Bridge. The Cabin John Bridge was actually constructed for the purpose of conveying the conduit across this ravine. The conduit actually is directly under the road, and when you look at the bridge from below, you'll see the arch. So the conduit is between the road and the arch. If you can look up there and envision the 9-foot diameter conduit in that section of the bridge, when you're walking in the conduit across the bridge, you don't even realize that you're in the bridge because the 9-foot diameter section doesn't change. It just happens to go across this ravine. The Cabin John Bridge was originally envisioned as a 6-arch bridge back when the construction was starting up at Great Falls. But by the time they got down here and the construction was actually, or the designs were being drawn and the construction was being planned, Montgomery Meigs, I believe, realized that if he constructed a single arch span, which he ultimately did, he would have the longest single arch masonry bridge in the world, which he constructed it that way, and Cabin John Bridge held that record for 40 years. As you can imagine, the construction of the bridge, considering the techniques available at the time, was quite an engineering feat. They constructed scaffolding up from below, and from the scaffolding then built the masonry structure up. So in the 1850s, it was quite an engineering feat to construct this bridge. This is the downstream end of the old conduit. You can see the 9-foot diameter circular section in there. Water at this point will have traveled completely by gravity down from Great Falls 10 miles through this conduit to this point. Now the conduit's presently out of service for renovation, but if it were in operation like it normally is, this conduit would be full of water. The water would flow out of the conduit through this structure, through these 2 sluice gates that control the flow, and into the reservoir. This is the receiving reservoir. It's now known as the Dalcarlia Reservoir. It was called the receiving reservoir when it was constructed because it received the water coming down from Great Falls through the conduit to this reservoir. In this reservoir, the water spends a period of time so that the particles could settle out, and that provided treatment of the water back in the 1860s when this process was put in. Over here is a building known as the Sluice Tower. The Sluice Tower is a Meigs designed building, designed and constructed in the late 1860s. It was constructed for the purpose of housing a large sluice gate used to divert water from the reservoir into a biconduit. Another Meigs building that was constructed as a part of this receiving reservoir is over here. This is known as the South Connection Gatehouse, and that gatehouse housed the sluice gates that would allow the water to pass out of the receiving reservoir into the Georgetown conduit and ultimately down to the distributing reservoir in Georgetown. The water would travel 2 miles then down MacArthur Boulevard from the reservoir at Dalcarlia here to the reservoir at Georgetown. It's now known as the Georgetown Reservoir. When it was originally constructed, it was the distributing reservoir. It came in the domed building at the end of the reservoir, and then the water traveled the length of the reservoir with particles settling out as it traveled to this structure where we're standing now. And this structure was built in 1868, and its purpose was to distribute the water then into the city, and thus the name the distributing reservoir.
All along the aqueduct are inscriptions that identify the people responsible for its creation. As engineer, Meigs's name appears most frequently. However, others are highlighted as well. Here on the side of what was then known as Union Bridge is a plaque that commemorates those who held federal office as the aqueduct was begun and completed. One of those named is the 1853 Secretary of War Jefferson Davis. In 1862, Secretary of the Interior Caleb Smith ordered Davis's name removed from the tablet because of his allegiance to the Confederate Army. In 1908, responding to protests, President Theodore Roosevelt had Davis's name restored to the tablet.